All righty, so page 120 is where we're going to start. This goes along with lesson 54. Okay, so lesson 54, page 120. In lesson 54, we were working with okay, so lesson we didn't get to subtracting, did we? I know we worked with addition.
We did subtracting.
Okay, we did. Okay.
Then we were done multiplication.
21. Yes.
Sorry.
All right, real quick, let's go ahead and talk for just a minute about our whole systems of equations. Okay, so with systems of equations, I have two equations that have two different variables in them. So typically I have an equation that has something with x and y, and I have another equation that again has x and y. So my whole purpose in all of this, when I'm solving systems, the first thing I've got to do is figure out how to eliminate one of my variables. Okay, and so the first thing that we worked on was solving by substitution or by setting them equal to each other. So we said, hey, if I can solve for y, if I have one equation, y equals mx plus b, and the other one I can solve for y and have mx plus b, then if y is equal to this and y is equal to this, since both of these y's are equal to the same thing, I can substitute. And I can say that this mx plus b is equal to this mx plus b. Okay? And in that situation, I've been able to eliminate y and focus on x. So I solve for x first, then plug in what I found for x and solve for y. Okay? So with this, my first thing is to eliminate one variable to solve for the other. And this is going to be my goal, whether it's substitution, elimination, whatever, or once we get to graphing. So my whole goal is I want to be able to work with one variable at a time. Then I plug in first variable solution to solve for second variable. And then my third step is to write solution as an ordered pair. And so that is whether we are solving by substitution or we're solving for by elimination. Remember, elimination is going to be when I am either adding or subtracting to be able to get to one of my variables. Now think about this. How are addition and subtraction related? How are addition and subtraction related? They're opposites. And I can convert from subtraction to what? Addition. I can convert to addition by adding the opposite, right? So let's think about this. Our first way of elimination that we worked with was addition. Our second way was what? Subtraction. But what did we turn it to? Addition. Okay. So I'm going back here. We're going to be working with multiplication and division But for both of these, I want to change it to addition. That way, I only have to learn one real way of elimination. I may have to get to it by either changing subtraction to adding the opposite, or I may have to multiply one or two of my terms to get to where I can add opposite terms, or I may have to divide one or two terms to get to where I can add opposite terms. Okay, so this was one way substitution where I say y equals mx plus b in one equation, y equals mxb in the other, and I can set them equal to each other. That is one method. That was the first method we learned, was substitution. The second method we learned was elimination using addition. And remember, our whole goal with addition is we want to add opposites to eliminate one variable. So the whole purpose when I'm adding is I'm looking for opposites to add together to be able to eliminate that variable. So instead of having to subtract and really pay close attention to, am I subtracting a negative minus a negative, or am I doing plus a positive, or what am I doing, and getting my signs all messed up and getting confused, let's change it to addition. And we're going to add the opposite. If I've got to multiply to get opposites, once I do that, I'm adding. If I have to divide to get my opposites, then I'm still adding. Okay, so one of the things that I was real bad, I've been trying to think about how to make sure where I eliminate. Okay, so really we have two main things that we've looked at here, but now we've looked at all the different possibilities that are involved with elimination. Does that make a little more sense? That basically whenever we're using elimination, our whole goal is to get it to where I can add the opposites and eliminate. Okay, so let's go ahead, and I'm going to go ahead and call out the answers for page 120, activities 2. And then any of these that we need to work, let me know. If you have questions, let me know. So the first one was solve by subtracting. So the first one, let's see, this is going to be 3x plus y minus 2 equals 0. And then we have 4x plus y plus 5 equals 0. My second one, my second equation is the one that I would change to adding the opposite. So I would have my original negative 3x plus y minus 2 equals 0. And then I would have plus negative 4x minus y minus 5. I mean, sorry, equals positive 5, because it would be a negative 5, then it would move. Okay, so the first thing is I have to change my second equation. So my solution, x is going to be negative 1, y is negative 1. Any questions on that one? Does anybody need me to work that? Please do not be shy and do not ask for help. And do not hesitate to ask for help if you did not get that answer and you're not sure. Okay, so the first one is negative 1, negative 1. My second one, remember the first thing we do is rewrite each equation in standard form, ax plus by equals c. Then we change the second equation to adding the opposite. So our second equation, our solution is 3, 8. Any questions on number on the second one? 3, 8. And then the last one, change the second equation to add the opposite, and my solution is 1, 1. Okay. So remember, I need to see your work. When you turn your work in, make sure that you've got your process. I don't want just an answer. I need to see what you did to get there. Any questions again on page 120? All right, let's go ahead and move to page 122. This was after lesson 55 on multiplication. Now, activities questions, I'll read the answer, stop me, and I'm happy to work a problem if you don't understand how we got it. Okay, so I'm going to go across the top. So 1, 2, 3, 4 across the top. So I'm on page 122, the first problem. Number 1, my solution is 3, negative 1. Any questions? Number 2, my solution is negative 9, 9. Any questions? My third one is 2, 3. Questions?
I have a question on the second one.
On the second one, the 3x plus 5 minus 18, that one?
Yeah.
Okay, so what I'm gonna do is first I need to erase it. All right, so let's see. I didn't want to have to go through all the trouble of setting up the computer, so I'm going to see if I can crop this to where. Maybe we'll be able to see it there, hopefully. That'll be able to see the board some. Okay, so for the second one, we have 3x plus 5y minus 18 equals 0, and x plus 2y minus 9 equals 0. What is my first step? What is the first thing I need to do? Standard form, ax plus by equals c. First step. So that means I'm going to have to add 18 to both sides of this one and add 9 to both sides of this one. So I'm going to end up with 3x plus 5y equals 18. And x plus 2y equals 9. Everybody good there? All right, remember my goal is to get this to an addition problem. So what I've got to do is I've got to try to make two of my terms opposites because I want to add the opposite. So I can either work with 3x and x, or I can work with 5y and 2y. Now I'll tell you, I prefer to always work with my first term just because when I get in the middle, I get kind of crowded and I mess things up. That doesn't mean I will never work with my middle term, but right here, it's going to be the easiest. So if I've got 3x right here in my first equation, what can I do to my x down here to make it the opposite of positive 3x? Multiply everything by a negative 3. Is everybody good with that so far? Does everybody understand why I'm multiplying by negative 3? Because I want this term to be the opposite of this one. So now I've got 3x plus 5y equals 18. And I've got negative 3 times x is negative 3x. Negative 3 times positive 2y is going to be negative 6y. And negative 3 times positive 9 is going to be negative 27. Remember now, I'm just going to add all of this up. Okay, so I figured out which term I wanted to make opposites. So I multiplied by whatever I needed to multiply by to make it the opposite. And now I've rewritten my problem. And now I just add vertically. 3x plus a negative 3x. These are the ones that I was trying to cancel out. So they're now gone. Okay, so now I have 5y plus a negative 6y. 5 plus negative 6 is going to be negative 1. So I have negative y is equal to 18 plus a negative 27. So what is 18 plus a negative 27? Negative 9. So if negative y equals negative 9, what does y equal?
Y
equals
negative, no, when.
Y equals 9. Okay, so remember, this is the same as multiplying by negative 1. So negative 1 times negative y is positive y. Negative 1 times negative 9 equals positive 9. Okay, so I can just look at it. Anytime I have a negative variable, I'm just going to take the opposite of what I have as my negative, and that's going to be my solution. So now I have solved for y. So now I know that y equals 9. So I'm going to go back to, I told you guys, I typically go to whatever my first equation was.
Plug in 9 value of y.
I'm going to plug in 9. So I have 3x plus 5 times 9. Why do I put that in parentheses?
Because that's where the y.
Because that's where my y goes. And my purpose for parentheses is I want to make sure if it had a negative with it, I want to make sure I use the right process. All right. So now I have 3x plus, what's 9 times 5?
45.
45 equals 18. What needs to move? 45. How does it move?
Subtract.
Subtract 45 from each side, and I have 3x is equal to
Negative 27.
negative 27. What's my next step?
Oh, we
Divide by three.
Divide by 3, divide by 3. So x is equal to negative 9. So now I write it as an ordered pair solution. X is negative 9, y is positive 9. Does that help, Zoe? Any other questions?
Well, the funny thing is, when I checked it, I got a true statement, so.
Okay. So something happened. I bet if you went through it, and if you want me to look back over it, I'm
I
happy.
know what I did wrong.
Okay.
But when I checked the wrong answers, I got a true statement, so I thought it was right.
Okay.
Maybe the book did it like if they have positive 9 at first and negative 9 back. What to do it the opposite way.
Your solution should always be, you should always end up with just a solution, okay? All right, so that was number 2. Our answer for number 3 was 2, 3. Any questions on that one? All right, the 4th one on the top row, my answer is 1, 2. X is 1, Y is 2. Any questions on that one? Moving down the road to number 5. Number 5, my solution is negative 3, 4. Any questions? Number 6, my solution is negative 9, negative 8. Questions on that one?
Question on number 5.
Question on number 5? Okay. So number standard form, just for sake of time. So standard form would be 5x plus 3y equals negative 3. And then 2x plus y equals negative 2. So now I'll look at it and say, hey, what's going to be the easiest thing to make opposite terms? Now, if I was going to make 5 and 2 opposite terms, I'm going to have to multiply both equations. And that's going to be a whole lot more work than I want to do. So in this situation, I am going to use my middle term. And I want to make these opposites. So what am I going to multiply my second equation by? Negative 3, because again, I want to make that the opposite. So multiply by negative 3, multiply by negative 3. So I have 5x plus 3y equals negative 3. Then I have negative 3 times 2x is going to be, was that negative 6x? Negative 3 times positive y will be negative 3y equals negative 3 times negative 2 is going to be a positive 6. Now I'm going to add them up. 5x plus a negative 6x is going to give me negative x. 3y, negative 3y cancel. So now I have negative x is equal to negative 3 plus 6 is going to be what? Positive 3. So if negative x is a positive 3, what is x? X is negative 3. Okay. Now I'm going to take x equals negative 3, plug it into my first equation. So I have 5 times negative 3 plus 3y equals negative 3. What is 5 times negative 3? Negative 15 plus 3y equals negative 3. What am I going to do first?
Add 15 to the 3.
I need to add 15 to each side. So add 15, add 15. So 3y is equal to negative 3 plus 15. 12. Divide by 3, divide by 3. So y equals 4. So I write my solution as an ordered pair, negative 3, 4. Any other questions? All right. So that was number 5. Number 6 was negative 9, negative 8. Any questions on that one? Did you say yes? No? Number 7, 5, 7. My solution is 5, 7. Any questions? Awesome. And then the final one, number 8, my solution is negative 7, 4. Negative 7, 4. Any questions on that one? All right, good job. Okay, so that finishes up homework. If you need a minute to make any corrections, you're more than welcome to. Remember, if you don't have something that you're gonna turn into me later, go ahead and have that. I'll get my stapler together. Did you make a note and stick it on there?
I know, it's really sad.
Now, go ahead and turn in your book to page 123. Page 123 in our book. Now we're going to work on division. So division is going to be exactly like we did with multiplication, except this time I may have terms that need to be divided so I can make like terms to add the opposite. Okay, so in the previous examples, we were multiplying to make like terms. Okay, that's fine. You just turn it on that thing. Okay, so if we look at lesson 56 on 123, it says sometimes systems of linear equations cannot be easily solved by any of the methods you've learned so far. When this happens, one equation can be rewritten by dividing each term of the equation by the same number to make one pair of variables match. In rare instances, both equations will need to be rewritten. So think about this for a minute. When I was multiplying by a term, notice that the distributive property tells me that I have to multiply my outside number by every single term inside. Okay? It's the same with division. When I divide, I have to divide each term by whatever I'm dividing by. Okay? Is this? Now I'm not taking, okay, so you put these are your, I need you to keep these. Yeah, I need you to keep your notes for this unit.
I don't think I can.
No, you should have them. Yeah. Okay, so Sadie, you get to keep this.
Oh my gosh, I'm 52.
Okay. So I do not need your notes that you guys printed off that we worked on. I don't want those yet. That wasn't in my list of things that I put on the board. So my notes. Keep that.
That's a little loud.
Set the turn down.
Oh, everybody? Oh, never mind. Did you hear me? Did you hear me? Well, I have the
This calculator is far more easy to use.
All right.
I don't understand how it works. You have to explain it.
So now, just like when we added our notes, if you want to add notes, since I did not type up notes for this section on division, if you want to write on the back of your notes like we added to our notes on multiplication, you're welcome to. You're welcome to take notes in another place. That's totally up to you.
Oh, we should keep this.
Yes, you're keeping that because that's the unit we're working on right now. Okay, so I want you to be sure to have that for test to study and stuff like that. Alrighty, so now we are moving on to division.
You blink. So you blink.
I have a blister from my shoes that I was wearing on Sunday. There's like 5 scars on my neck. And I got a blister. And I got one and several. I think so. She's not like she's yelling at me to yes. Yeah, it's still here.
I have so many all over my feet. I don't really have to look at my hands.
Because it was so I get sparkles and for like
I would honestly, I would rather sparkles.
All right. So if we look at page 123 in the red box. Page 123 in the red box. And so it says solve the system of equations. So our example is 3x plus 2y minus 4 equals 0 and 6x plus 18y plus 6 equals 0.
I think I'm, wait.
In the red?
Oh, right.
Yeah, we're right here.
Okay, sorry.
Okay. So the example that they're giving us to look at. Okay. So what is my first step always going to be? Standard form. So the first thing I need to do is I need to do standard form. So that just means I'm moving my last term from the left-hand side to the right-hand side. If it's positive, when it moves to the other side, it's negative. If it's negative, when it moves to the other side, it's positive. So they rewrote it in standard form. So now, when they rewrote in standard form, you can see, and I'm right here, it has 3x plus 2y equals 4 and 6x plus 18y equals negative 6. So when I'm looking at these terms, I've got 3x and 6x, and then I have 2y and 18y. I want to make one of these opposites. Okay, I need to have one pair of variables opposites, so when I add them, they're eliminated. Y'all know that I'm always looking for the easiest way to do it. Okay, I don't want to go to the most difficult. So when I look at what I also have to think about is if I'm going to divide by a number, when I multiply by a number, that's super easy because I can multiply. But when I divide, it's more difficult because notice if I said, hey, I want to make 18 and 2 be opposites. What would I have to multiply 18 by to get to 2? Does everybody see where I am right now?
Yes.
If I'm looking at, actually, let me write this up on the board real quick and then that way we can look at it a little bit better. So if I've got 3x plus 2y equals 4 and 6x plus 18y equals negative 6. If I was trying to make these opposites, what would I have to do to 18?
Divide by negative 9.
I would have to divide by negative 9. Is it going to be easy to divide 6 by negative 9?
No.
No, that's going to be hard. I don't want to do that. I can't do it. Okay. It's going to be a challenge. So that's how I know. So when I'm trying to figure out what I'm going to divide, I have to look at not only my first term, but my second term as well. And my third term, because I'd have to divide this by 9 and I'd have to divide this by 9. And I don't want to do that. So the easiest thing is going to be to work with my 3 and 6. What would I divide 6 by to get the opposite?
Wait, negative.
What would I divide 6 by to get the opposite of 3? I would want to I would want to divide. What is 6 divided by what is 3? 2. So I'm looking at dividing by negative 2. Can I divide 6 by negative 2? Can I divide 18 by 2?
Yes.
Can I divide this negative 6 by 2?
Yes.
Yes. So now I have to test each term within the problem to make sure that it is going to be divisible by whatever number I'm trying to divide by. Because like I said, if I try to divide everything by 9, that's not going to work. Okay. but I can divide everything in my in my second equation by 2. So I'm going to divide by, and remember we want it to be opposite, so I'm going to divide by negative 2. So I'm going to divide by negative 2. So now I'm ending up, actually, I don't want that there.
Actually, I think it's divided by the positive 2.
The book is a little bit different. Remember, I'm trying to teach you just to go to adding the opposites. I don't want you to have to remember separate directions for subtraction and stuff. So this is going to be a little different than the example in the book. So I'm dividing by a negative 2. So I still have 3x plus 2y equals 4. 6x divided by negative 2 is?
Negative.
What is 6 divided by negative 2?
-3.
Negative 3, so it's negative 3x. What is 18y divided by negative 2?
9.
Negative 9y. Remember, since it's a negative 9, that's why I now have minus 9. Okay? Now I have negative 6 divided by negative 2.
3.
Positive 3. Okay, so now remember, I want to add. In the book, they're having you subtract. But again, when I subtract and I have to look at 3 minus 3x, that's fine. But when I do 2y minus 9y, this is where mistakes start happening when I'm not paying attention to my signs. So that's why I'm trying to teach you to just change it to where I'm going to add the opposites. So again, now 3x and negative 3x cancels out. What is 2y plus a negative 9y?
Negative 7.
Negative 7y equals, what is 4 plus 3?
7.
7. Divide by negative 7. Divide by negative 7. And y equals?
Negative 1.
Negative 1. So now I found negative 1. I'm going to plug in negative 1 to my first equation. 3x plus 2 times negative 1 equals 4. 3x, what is 2 times negative 1?
-2.
Negative 2. So I have 3x minus 2 equals 4. What do I need to do now?
Add 2.
Add 2 to each side. And so 3x is equal to 6.
Divide by 3.
Divide by 3, divide by 3, and x is equal to 2. What is my solution?
2, -1.
Did we get the same solution as the textbook, even though they subtracted?
Yes.
Yeah.
They just have more stuff.
Okay. They subtracted. To me, it is easier to change it to addition. Then you only have to remember rules for addition. Okay. You don't have to be as careful, you know. Adding with those signs are going to be. Okay, I've got a Zoom recording, so he can watch it later. He can watch it later if he feels like it.
You got a big head.
Bless his heart.
You got a big head.
He's got a big head. He is not. Micah, if you watch this, that was your mom that said you had a big head. No, I just said that if he watches it later. Thank you. Okay, so Micah has a big head. All right. So our solution is 2-1. So now we're going to work through the examples and classwork. Okay. So our first one in classwork, I have 2x plus y minus 5 equals 0, bless you, and 4x plus 12y minus 20 equals 0. What's my first step?
I turn to standard form.
Standard form. So I have 2x plus y equals 5, and 4x plus 12y equals 20. Now I'm looking to see what do I want to make opposites to be able to add. So I have a 2x here and a 4x here. So what can I do to 4x to make it the opposite of 2x?
Divide by -2.
Divide by -2. Here I'd have to divide by 12, but that means I'd have to divide this by 12 and this by 12, and that's not going to work. Okay, so here I can see that I'm just going to divide by, we want to do -2, don't I?
Couldn't you do 4, 2, or not?
Divide by 4.
Oh, wait, never mind.
Okay, so I can divide by -2. So I would actually, we'll just keep on going out to the side. So I'd have 2x plus y equals 5. plus negative 2, I'm sorry, 4x divided by negative 2 is negative 2x. Positive 12y divided by negative 2 is negative 6y. 20 divided by negative 2 is negative 10. Now I can add them up. 2x plus a negative 2x cancels. Now I have y plus a negative 6y. What is my understood number in front of this y?
1.
So this is like saying 1 plus a negative 6 is negative 5y equals 5 plus a negative 10. Negative 5. Divide by negative 5, divide by negative 5, and y equals 1. So now I know that y is equal to 1. I'm going to take my first equation, which is 2x plus y equals 5. I'm going to say 2x plus 1 equals 5. So I'm going to subtract 1, 2x equals 4, divide by 2, divide by 2, and x equals 2. So my solution is 2, 1. Any questions on that? Anything that I did that you're not sure of? Okay, let's look at the next one. I have 18x plus 12y minus 6 equals 0. 6x plus 9y minus 12 equals 0. First step, standard form. That means I add 6 to both sides here, add 12 to both sides here. So I have 18x plus 12y equals 6. 6x plus 9y equals 12. Now, remember we're doing division, okay? Later on, when you're given a problem, you're going to be able to choose what method you want to use. Subtraction and division are not my favorites. I prefer to add and multiply all day long versus subtract and divide. I don't know about you guys, but that's just me. And this one here, if I had this problem, if my directions were not telling me that I had to divide in this section, I would have chosen to multiply this by -2. Okay, so know that there's more than one way to solve these. Right now, we're just looking at all the possible ways so you can learn the different methods, because sometimes you can't just multiply. I guess realistically, you could always multiply because, anyway, we'll get there. Even if I had to multiply this one, I could multiply. I'm going to have some really big numbers to deal with. So you could always multiply, but it's not always going to be the best option, okay? To keep your numbers as simple as possible, multiplication may not work for bigger, or maybe more difficult for bigger numbers and give you more room for mistakes, okay? So again, I could multiply to solve these, but right now my directions are to divide, so that's what we got to do. All right, so I'm looking here. I have 18x and 6x, and I have 12y and 9y, and then I have 6 and 12. So I'm looking at what could I divide one of these by to make the other? So what could I divide 18 by to get to 6? 3. So I would divide by -3, right? Can I divide 12 by -3?
Yeah.
Can I divide 6 by -3?
Yeah.
Yes. So whenever I pick a number to try to divide by, I have to check it with each term to make sure it is divisible by that. So we said we're going to divide the first term by -3. Yes. Take a break and we'll come back and do that.
Yes.
Oh my God. Get out, Sadie.
Lipstick on this one. Wash it off and it never comes off.
Oh.
I think it's like
You're
that one.
Oh.
Okay. Give me your opinion on this format. Is this better?
I like it.
Are you following better? Are you able to?
Oh, yeah.
Good.
Yeah, then I don't have to like turn it.
Because that's my goal. It just wasn't working. I
Yeah.
felt like people either weren't paying attention or people were distracting others. Or it was just harder to follow.
Yeah.
Okay, great.
How's it going?
Good, how are
In
you?
person, I'm good. Thank you. So
Very good.
can you tell any difference whatsoever?
Yeah, well, and one of the things is she made a very mature choice because they came in and sat down. Usually we have a room like where it's like the tables are together and all the edges like that, and I'm up here, and it is just, it's hard to follow.
Yeah.
Okay? And so when we separated the tables to sit down, and she was back here between Myra and Jack.
Oh,
And so I said something, she said something about focus or whatever, and she said, "Sort of focus on something." I said, "You can decide where you want to sit, but you may be able to pay better attention when you're in front of me." She got her stuff and she moved on up. And she said, "It will help me," she said, "It will help me pay better attention if I'm right here at the front." She said, "I can socialize when it's break time." I said, "That is a very mature choice." I said,
the Lord is far away with the medicine.
"Good."
I mean, I'm talking about like,
I've just seen a big change over her in the last these last several months, and that's what she said. Good. Because she seems more confident just in her presentation. She doesn't seem as busy. She's not talking as much, but
that's what I thought. I don't.
yes.
Hey, Micah. I have to say,
That's what she said. She said that she didn't say that.
No, tell me it did not work last night. So maybe it will, but yeah, so, and we just. Yeah, I don't know.
You're
I'm just gonna say that.
Wow.
I had to do it.
What's that all about?
Huh?
What's that all about?
What's that all about? Recommenting on your eyebrows? I just think they're really pretty.
But talking about someone.
Who?
The guy you just had like a 15-minute with.
A guy? What? Guys are nasty. What are you talking about?
Oh, hold on. I can't.
There you go.
Wow, this made my eyes.
And
You can do that.
I can't do that anymore.
I'm not.
Probably at the moment.
Okay.
I'm gonna do my backpack for you.
What? Yeah. I didn't see that.
I don't know.
Okay, bro, what? We're spread out anyway. It's like, I don't see. Yeah, we're spread
That's how you should get. It's not fair.
It's an old chest.
No.
Yeah, and I'm like,
Not bleach, but like, I don't know if the weather is something like that. But yeah. They just like the door was like no, lunch is after this.
Yeah.
wow. I'm so excited to eat. I'm so hungry. Hey, your hair looks good. Yeah, it does. My hair looks good too, because I straightened it. Wait, what did she say? She said,
I know. You do that every time.
It's so sad though.
it took me like 30 minutes. Yeah.
No.
Oh, yes, please replace her.
All right.
Hey, I like that. I like it.
Here we go. So we had just looked at this one and we said,
I don't even know why they had that.
Oh, wait, I want to see if I can.
Then again, she like.
all right, deep breath in. Deep breath out.
And then just goes all back into your mouth.
Yeah, deep breath in and breathe in again. All right. So we said we are dividing and we said we are looking to see what can we divide by to make opposite terms to be able to cancel something out. And we said we would divide by a -3. So here we go. We have got 18x divided by -3. -6x. 12y divided by -3. -4. 5. 6 divided by -3
-2.
equals -2. Bottom one staying the same. So I'm going to have plus 6x plus 9y equals 12. All that stays the same. Line them up and out. -6x plus 6x cancels. So now I have -4y. Do not forget the sign in front of your middle term, okay? It's very easy to look at that and go, oh, that's just 4y. It is -4y. So be careful about your signs of the middle terms especially. -4y plus a positive 9y. -4 plus 9.
-5.
Not negative because my negative is with my smaller, so it's a positive 5y. And then -2 plus positive 12.
10.
Not negative, it's gonna be a positive. Take the sign of the larger and find the difference. So 5y equals 10. So what does y equal? Whoops.
2.
Y equals 2. So my ordered pair solution for this one, I do not have because I just solved for one. So I said y is equal to 2. So we're gonna plug it back in and I'm gonna start with this one. So I have 18x plus 12 times 2 equals 6. 18x. 12 times 2 is
24.
24 equals 6. Subtract 24, subtract 24. 18x is equal to, what is 26 minus 24? What kind of 18? -18, divide by 18, divide by 18, and x equals -1. So now my ordered pair solution is -1, +2. Any questions? Okay. So let's go ahead and turn the page to 124, activities 2. 124, activities 2. We are going to do the first and last problems on this page, and the rest of it will be for homework. Okay, so we're going to do the first one and the last one.
You want homework on paper?
Homework will be on paper, but you can do the first and last in the book. And so what we will do is we'll go ahead and number these so everybody's good. We don't have a number mess up. Okay, so in the book, 1, 2, 3, 4, 5, 6, 7, 8. There are 8 problems in the book. Okay, so 1, 2, 3, 4, 5, 6, 7, 8 problems. We are going to do these 2 together. All right. So we're doing the first and last together. So we're going to make this one number 1. This one's number 2, number 3, 4, 5, and 6. If you numbered them differently, change it. No, I'm just kidding. So just go ahead and mark out, but don't number the first one or the last one.
I did that.
Okay. So the first one we're going to do together that you can do in your book is 6x plus 4y minus 14 equals 0. 2x plus 8y plus 2 equals 0. First step.
It's standard form.
Standard. I need to add 14 to both sides here and subtract 2 from both sides here. 6x plus 4y equals 14. 2x plus 8y equals -2. Now I'm looking to see what do I want to divide by to make opposite terms. What could I divide 6 by to make 2?
I have a question.
What?
So like you can also divide 8y.
Okay, so we're gonna get there. So hang on just a minute. If I wanted to divide by 6 by something to get to 2, what would I divide by? 3. So that means if I divide this one by 3, I have to divide this by 3 and this by 3. Is that gonna be my best choice? No. So now I'm gonna look at my y terms. Okay. So now what would I divide 8 by to get to 4? 2. Can I divide this by 2? Can I divide this by 2? So that's how I know what I want to do.
-2.
Okay, so I'm dividing my top problem by -2. By -2. Okay.
Your bottom problem.
Yeah, my bottom problem.
Okay.
-2.
I was confused when I'm being the top.
There we go. All right. Y'all know sometimes my hand starts flying faster than my brain works. Okay, so now I have 6x plus 4y equals 14. And I have 2x divided by -2 is going to be what? Okay, so 2 divided by -2 is a -1. And we've got a variable x here, so I have -x. 8y divided by -2. -4y. And then -2 divided by -2. Positive 1. Good. Negative divided by negative is a positive. 2 divided by 2 is 1. Add them up. 6x plus a -y. 5x. I said y. 6x plus a -x. 6x plus -x.
Cancel.
6x. We're going to start this over. 6x plus a -x equals 5x. All right. And 4y plus a -4y cancels out. Equals 14 plus 1, 15. Divide by 5, divide by 5, x equals 3. I'm going to plug in my 3 to my first equation, which is 6x plus 4y equals 14. I'm going to have 6 times 3 plus 4y equals 14. 6 times 3 is 18 plus 4y equals 14. Subtract 18, subtract 18. 4y equals -4. Divide by 4, divide by 4, and y equals -1. My ordered pair solution is 3, -1.
I don't know how your hands move so fast.
Like I said, my hand moves faster than my brain. And so a lot of times it just, does not like the correct
This is
thing.
a picture of myself is four like fastest in the universe. And at the end, the fourth one is math teacher's handwriting.
Well, one of the things that I don't know if I probably told some of y'all this, or I don't know. But anyway, when I was little, like ADD, ADHD, all that stuff was not a thing. Okay. And so like, obviously I have something, but it was not a thing when I was little. And it was even the kind of thing where the doctor even told my mom she needs medicine, and my mom's like, nope. So anyway, long story short, as an adult, I was diagnosed with ADD or ADHD or whatever.
It's
because-
ADHD.
Anyway, yeah, mine is the impulsivity, and it's a lot of times it's my wah. So anyway, but being old, trying to take ADD medicine with an old heart, it does not work very well. So that's why a lot of times, so I can empathize a lot with a lot of people that have that same struggle, because y'all see, my hand works faster than my mind sometimes, and it's just, so I have to stop and take a breath and think through it, okay? Because it is, we all have challenges, whether it's, some type of learning disability or some kind of other disability or other kind of learning challenge or whatever, we all have something, okay? And that's one of the things that I finally had to learn. I think growing up, I always thought you had to be perfect, and you always had to have your stuff together. You always had to present perfect on the outside. And then I was like, how do I have so many issues and everybody else is perfect? What's wrong with me? And then I finally realized everybody has issues, and it's okay. So anyway, so it's okay. We all have struggles. We all have things that we're good at. We all have things that we have trouble with. It's all right. And so that's one of the things that I want you guys to always think about is we all have learning. We all learn differently. Okay. I'm a very visual learner. I need to see it ordered out. Some of you guys, and why is it usually boys too, Jonas? A lot of y'all can do things in your head. I can't see it. If I can't list it out, I don't have that ability. So we all have different ways, okay? Now, the main thing about math is I know, and Mark, y'all, you like to do things in your, I think all the boys like to do things in their head and just, I don't know what it is.
I realize
It's not manly to write it down.
But anyway, but the main thing as a teacher, I just have to be able to see things listed out, and it's not for me. It's so I can see that you know the process, and then eventually at some point you're going to be allowed to do stuff in your head. Okay, it's going to be fine, but for right now, I've got to make sure you've got those basic foundations. So anyway, all right, our last problem.
You have the impulse. I have just the OCD thoughts, the what ifs.
Well, that's what it was funny because when I was an adult and I was like, I just can't. I said it's like my, all this stuff and going on. So I had to do this little test, and it was so funny because I was like, I got this. It was this little test, and there was a line on the screen, and I had a little thing in my hand, a little clicker, okay? And there was a box, like no lie. This is what it looks like. There's a box, and if it was above the line, I needed to click. If it's below the line, don't click. Simple enough, right? If it's here, click. If it's down here, don't click. So I'm like, I got this. So like I see the box, click. It's down the bottom, I don't click. See the box, click. Down the bottom, nah. So anyway, then it starts speeding up, and I'm going, and I
It's
just,
an impulse.
so, yes. So
Yeah,
anyway,
I had to do that with letters, and
Yep.
it was don't click on the X or click on every letter, and it. I
by
was
golly,
trying to
I've been
find
clicking
tricks.
all day long.
It's completely random. There is no.
So anyway, so that's my messiness for you guys to know that, so I make mistakes. And that's why one of the other things also is that, I'm not a mathematician. I know how to teach math, but if I sat down with problems again, I'm going to be writing them out step by step because that's my ability. That's what I need to do to get things right. So it's the kind of thing where I encourage all of you guys, especially at the age that you're at now. It's real easy to look at other people and get wrapped up in what they're doing and what you think you should be doing based on what other people do or what's on social media, and which I'm convinced is from the devil now. But anyway, so it's the kind of thing where We all have to go through those times. And I guess my encouragement to you is be proud of who you are and be strong in your identity as who God made you to be. Because God doesn't make mistakes. I can get a little hyperactive sometimes, I can be impulsive, but that was not God's mistake. It was his way of making me exactly how he wanted me to be. And so one of the things that I strongly encourage you, because I know that friend relationships can be really difficult at this age. And I know, yeah, I know that there's so many different things. You're trying to figure out who you are and what you are. And somehow I've gone off on this weird tangent that has nothing to do with math. That's okay. That's okay. So my encouragement though, for real. It's funny, my kids always tell me about the one teacher that they always knew. I think it was their Spanish teacher in elementary school. They'd be like, we always knew how to get her off task. You just asked her, tell us about your salvation story. And she said every single time she'd go off. So don't think y'all are gonna be able to get me off topic every single time.
You got me, you sly dog, you got me monologuing.
Yeah, exactly. It's so incredible. I love it. Okay. The main thing is we all make mistakes. We all do things. Okay.
Amen.
I try to catch my mistakes, but sometimes I need y'all to tell me when I've written a Y up there that's supposed to be an X. Y'all tell me it's okay. It's not gonna hurt my feelings. I don't go, and this is what my son does. When I try to tell him something, he goes, you're just saying you're dumb. I said you made a mistake, so fix it. So when I tell you guys you've done something wrong, I'm not saying you're dumb. I'm just saying you made a mistake, fix it. When I've written a bar on the board, you're not telling me I'm dumb. You might be. Okay. Let's go back. Let's look at the last problem on this page. Notice they were kind enough to even give us some notes that says, hey, you're going to need to divide both of them. Okay? So that way you didn't sit and go, oh my gosh, these are really giant numbers. All right. And I can't divide 18 by anything to get to 12, and I can't divide 24 or 30 by something. So anyway, I start out with 12x plus 30y minus 36 equals 0. And 18x plus 24y plus 30 equals 0. First step, standard form. I need to add 36 to each side, subtract 30 from each side. 12x plus 30y equals 36. And then 18x plus 24y equals negative 30. All right, so if they had not told us what I needed, that I'm gonna have to divide both equations, okay? And I was looking at this, my first thing would be, can I divide 18 by anything to get to 12? No. Can I divide 30 by anything to get to 24? No. So that's my first indication is if I look and say, hey, I can't do it, then I start looking and I could either pick my first terms or my middle terms. Y'all know I like to work with the first one because that's just how I am. So I've got 12 and 18 here. But again, whatever I divide both of them by, I have to be able to divide every single term in the problem. Huh? Okay, Jonas wants us to divide by 6. So if I divide, can I divide 12 by 6? Okay. I can divide 12 by 6, and what am I going to get? 2. What if I divide 30 by 6? 5, and 36 by 6. Okay, so I have 2, 5, and 6. If I divide this one by 6? 3. Are those going to match? If I divide this by 6? Are those going to match? If I divide by 6 here? Okay, so, but think about if I can't divide both of them by 6, but if I divided this one by 6, what did I get here? 2. What would I have to divide by here to get to 2? 9. What would I have to divide by here? 9 here. Okay. What if, so now I've got to step back and think about that.
Well, since we're supposed to find both equations, but maybe it's different.
Well, no, so maybe it's not. So let's try a different number. Okay. What if I divide this by 2? Can I divide this one by 2? Can I divide this by 2? And this by 2? If I divide this by 2, what do I have here? 12 divided by 2 is going to be 6. What would I have to divide 18 by to get 6? Can Can I divide this by 3?
Yes.
Can I divide this by 3?
Yes.
Yeah. So I'm gonna divide my top one by 2. So let's go ahead and write that one out. What is 12x divided by 2? 6x. What is 30y divided by 2? 15y. What is 36 divided by 2? 18. Is 18. All right. So now I need the opposite of 6x. So that's going to be what?
I have a question.
Negative 6x. So I need to divide to get negative 6x. What am I dividing 18 by to get negative 6x? Divide by negative 3. What's your question, Zoe?
I did -2 and +3. Does that give me the same answer?
Yes.
Okay.
So even if you did your top by a negative and your bottom by a positive, it's still going to work out because your first terms are going to be opposites. You're still going to get the same answer. So 18x divided by -3 is going to be negative 6x. And 24 divided by -3. What's 24 divided by 3? 8. So 24 divided by -3 is going to be -8. And -30 divided by -3, a negative divided by negative is a positive 10. So now I have my first terms are the same. So I'm going to cancel those. And then 15y plus a negative 8y. 7y. 18 plus 10. 28. Divide by 7, divide by 7, y equals 4. Now we're going to plug 4 in to our original equation. Ooh, that's going to be a big old number with either one that I use. So 12x plus 30 times 4 equals 36. 12x plus, what's 4 times 3? 12. So what's 30 times 4? 120. Equals 36. Subtract 120, subtract 120. And 12x is equal to a thank you, Zoe, negative 84. Now what am I going to divide by? 12. Divide by 12, divide by 12, and x is equal to
7.
what kind of 7?
Positive.
I've got a negative divided by a positive.
Oh, -7.
Higher number.
Negative 7. Okay, remember when I've got opposites, it's going to be a negative. So my solution is -7. Any questions there? Okay, so our homework is page 124. We are going to finish up that section. But now what I want to do so basically the section on linear combinations is multiplication and addition, and that's what we've been doing. I went ahead and taught you guys that whether I need to subtract and turn it to addition, I'm going to add. If I multiply or divide, I want to turn it to adding the opposite. So that's what this section is telling you to do, is to, and also know that sometimes I might, just like on this one, sometimes I have to divide both equations to be able to get common or to get opposites to add together to cancel out. Sometimes I may have to multiply both equations to be able to get, but my whole goal, my whole purpose is to find those opposite terms. So when I add them together, they cancel out so I can focus on the one variable that's left. Okay. So now let's go ahead and turn to page 127. We're skipping lesson 57.
I'm gonna go back and do it or no?
No, because we've been doing it. So there's no sense in just doing extra work just to do work. So look at lesson 58. Lesson 58 says linear systems may be solved by setting the two equations equal, addition, subtraction, multiplication, division, and a combination of these methods, or linear combinations. No matter which method you choose, there are 3 important things to remember. Step 1, write in standard form. Step 2, express your answer as a coordinate point. And step 3, check your work to make sure your answer works in both original equations. Okay, so with all of these, when I have -7 as x and 4 and y, if I were to plug -7 here and 4 here, I'm going to get a true statement. Okay. When I plug it into my second equation, I'm going to get a true statement. So let's go ahead and look at the example. The example in the red box, I've got 3x plus 2y minus 7 equals 0. Actually, you know what? I think I want to change up. I'll look at this a little differently. We start out with 3x plus 2y minus 7 equals 0, and 6x plus 4y minus 15 equals 0. When I look at any linear system, the first thing I want to ask myself is, can I solve for y equals mx plus b? That's my first question, because if I can, that's my easiest way. If I can solve each of these for y, then it's much easier. If I cannot, if it's yes, solve by substitution. No, move to number 2. Number 2 is to write each equation in standard form. Ax plus by equals c. Okay, so what I'm going to do is I looked at these. I cannot solve for y. Y is not by itself to be able to solve for y, so I'm moving on to number 2. I'm going to go to standard form. 3x plus 2y is going to equal 7, and 6x plus 4y equals 15. Now, step 3, I want to look at all possible ways to get a pair of opposite terms. Okay, so in this one, I've got 3x and 6x. One of the things I could do is, what if I multiplied both of them? Well, first of all, I'll look for opposite terms. Do I have any? No. So then I'm going to move on. What can I multiply 3 by to get to 6? 2. So I could multiply and add and cancel my opposites. Can I divide by anything? Yeah. If I divide, what would I divide 6 by to get to 3? 2. I would divide by 2, but then I divide that by 2 and do that by 2. Could I do that and have that as 7.5? I guess I could. It's not going to be the easiest. So what I do is I'm looking at my problem and saying, what are all the possibilities here? Do I need to multiply? Do I need to divide? Is there anything that I can do? So step 3, this is the place where you get to choose what you can do. Now in this one, there might have been several other things that I could have done, just like Zoe said, hey, I wanted to divide this one by a -2 and this one a +3. Is that okay? Absolutely, you're going to get the same answer. So I can look at it and I want to figure out what are all the possible ways that I could solve it, and then I just get to pick the way I want to use. Okay, so once I do that, my 4th step is going to be to add, to cancel opposite terms, and solve, that's my for remaining variable. 5, plug in solution for step 4 and solve for other variable. And then 6, write solution as ordered pair. Now step 7, this is an optional step. plug in values to check. Okay? If you want to plug in your values to check and make sure you got the right answers, then plug them in and check your work. You don't have to. You don't have to show me that work. But if you want to make sure that you've gotten it right, then take the time to do it. Okay? Again, yes, it takes more time. Sometimes we just don't feel like doing it. But it will keep you from getting the wrong answer on the test. Okay, so we looked at this one.
We're having a test.
No, eventually, yes. Not right now. Okay, so we're back at this problem. 3x plus 2y equals 7 and 6x plus 4y equals 15. What do you think we ought to do to that one to make an opposite term to be able to add?
Multiply by -2.
Which one do you want to multiply by -2?
3x plus 2y equals 7.
Okay, we want to multiply my top by -2. So I've got -2 times 3x, -6x, -2 times +2y is -4y. 7 times -2 is -14. This is all staying the same, and I'm going to add them together. 6x plus 4y equals 15. Huh. Take a look at this.
Whoa.
What is -6x plus 6x?
That's
0.
0.
That cancels. Is 0.
But that cancels.
But it does cancel too. What is -4y plus 4y? So this side is 0, right?
Yeah.
What is -14 plus 15?
1.
This would be it's a 1.
It's
a negative 1.
Does
Yes.
0 equal 1?
No solution.
No
Same thing,
solution.
basically our answer is
0 does
different.
not equal 1, so there is no solution to this problem. So if you ever get to where you cancel both x and y, unless this said 0 over here, now if 0 equals 0, but then basically your both x and y's would be 0, okay? But if you end up with a statement that is not true, no solution is your answer, okay? So let's look at classwork 1 on page 127. Okay, I have 5x minus 2y minus 5 equals 0, -3x plus 4y plus 3 equals 0. All right, which two terms do we want to make opposites?
Oh, the
y.
y.
Say the y.
Standard form first. Okay, y'all want to, yeah, the y's are going to work the best. Now, if I wanted to multiply, I could multiply this by 3, and I could multiply this one by 5 and make these both 15 and -15. So I could multiply, or I could multiply to make these match. It doesn't matter, okay? So just know that there's not just one right way to do it. We'll go ahead and write 5x minus 2y is equal to 5, -3x plus 4y equals -3. Okay, so I would much rather multiply one equation than having to multiply two equations. So again, I'm going the easy way. I know that if I multiply my first equation by 2, then I have the opposite of 4y. So now I have 10x minus 4y equals 10. -3x plus 4y equals -3. Add them up. 10x plus -3x is
-7x.
Okay, which one is my positive,
Wait,
larger or smaller?
Positive.
Good, +7x. Tab, did you have a question?
How come we're not dividing?
Okay, what would you want to divide by? What would I divide by?
Maybe.
Okay, if I divided by 2 here, that means I have to divide 3 by 2, and I have to divide 3 by 2. Can I easily divide 3 by 2? So I don't want to deal with fractions or decimals. So if I cannot divide if I can't divide each term to make a whole number, I don't want to do it. Okay, so good question. Okay, so 10x plus a negative 3x is positive 7x. My negative 4y plus 4y cancels out. 10 minus or plus a negative 3 is 7.
X equals 1.
Good. X equals 1. I'm going to plug it into my first equation. 5 times 1 minus 2y equals 5. 5 minus 2y equals 5. So I'm going to subtract 5. So I have negative 2y equals 0. What am I going to divide by? Divide by negative 2. Divide by negative 2. What does y equal? 0. Good. Remember, a 0 in my numerator is okay. A 0 in my denominator can't happen. Okay? So maybe if you think thumbs up, if your 0's in the numerator, thumbs down if it's in the denominator. Can't be done. So my ordered pair solution is going to be 1, 0.
How can you divide 0?
Huh?
How can you divide 0?
We can't, well, I mean, 0 divided into 2 parts,
Is still 0.
you have 0. Okay, so if I said I've got 0 and I want to divide it into 2 parts, but I can't divide 2 into 0 parts. Okay, so I can divide into 0, I cannot divide by 0. All right, let's look at let's do the first one of activity. Actually, let's do the last one of activities 2.
Can I go to the bathroom?
Activities 2 at the bottom. We're going to go ahead and do the last problem. So in activities 2, you can number the first ones 1, 2, 3. Fun out there.
Are they going to
So that'll be 1, 2, 3 will be for homework. And then the last one we'll do in the book. Does not have to be. So the last one we're doing in the book. The first 3 will be on paper. All right, so we have x. Nope, that's the first one. 5x minus 3y minus 6 equals 0. 10x minus 6y minus 12 equals 0. We're going to go standard form. 5x minus 3y equals 6. 10x minus 6y equals 12. All right, so I want to think about what do I want to do to make opposites. Okay,
You could divide by 2.
I could either divide this one by 2 and get there, or I could multiply by this one by 2 and get there. What do y'all want to do? Y'all want to multiply? Y'all like multiply better? All right, let's multiply by a negative 2. So I'm going to have negative 10x plus, since I have a negative 2 times a negative 3, that's a positive, so plus 6y is equal to negative 2 times 6 is negative 12 plus 10x minus 6y equals 12. That's awfully interesting, isn't it?
It's 0.
What's 10x plus, negative 10x plus 10x cancels out. 6y plus a negative 6y
Oh, and it's 0.
cancels out, and negative 12 plus 12. So 0 equals 0.
We're just doing a bunch of
All right, so look at this one. Does 0 equals 0 make a true statement? It does make a true statement. So let's look at this. My division.
What about the equal 0?
So remember a minute ago when we said it did not equal, when we had 0 does not equal 1, and we said that was no solution? Because it was a false statement.
This is a false statement.
This one is a true statement, right? 0 does equal 0. So my solution is all real numbers. Okay, yes.
Isn't that negative 12 supposed to be negative 24?
We only multiplied 6 by negative 2. We didn't multiply the bottom one.
Oh, yeah.
We didn't multiply the bottom equation.
Oh, yeah.
What's
Okay.
with the little squiggly one? real part.
It's an S.
Numbers, that's just an
Oh, that
S,
makes sense.
sorry.
Dyslexia, and I was like, what is
All right, so now here, my solution is all real numbers. If it's a false statement, if I end up canceling out and it's not true, it's no solution. If, once I get here, if I have 0 equals 0, then my solution is all real solutions, yes.
Ms. June, if 0 equals 0, wouldn't that equal the origin, and that could be coordinate plane too?
Well, remember an origin is gonna be an ordered pair, so that would be where I have X and Y as an ordered pair. So,
there's no extra Y?
basically what this is saying is that if I put 2 in for X and 3 for Y, I'm gonna get a true statement. If I put a 5 in for X and a 2 in for Y. So basically it's saying I can put in all numbers for X the same and all numbers for Y the same, and I'm gonna get a true statement is what it's saying. That I don't just have one answer. Now, one of the things that we haven't gotten to yet is, or we talked about it briefly. Think about when we have written our problems and we have ended up with, say my answer was -1, 2. What is that?
Like a coordinate.
It's a point on a coordinate plane, right? So basically, if I have my X and Y axis, X, Y, and I said this was -1, 2, that means I start at the origin, I go left 1 and up 2. Okay, so that would be like -1, 2. So basically what this is telling me as my solution is my 2 equations. If I graph both equations, this is where they intersect. So that's what, like if I graphed one equation and it went that way, and I graphed this equation and it went that way, my solution is where my 2 lines intersect. So in that situation, I don't know what the graph would look, I mean, I don't know anyway, but basically my 1-point solution is telling me where my lines intersect. So here, if I have no solution, if I have lines that never intersect, what kind of lines are those? They're parallel lines. So think about on my grid, if I were to graph that one, that means that when I graphed my 2 problems, I've made parallel lines, because remember, parallel lines will never intersect. When I have an ordered pair solution, that means my lines have intersected at one place. When I have no solution, my lines graphed make parallel lines. So if it's all real numbers in this situation, let's say this was my line that I graphed. This equation, if it looked like this, then this equation here graphs right on top of it. So this is a line that lies on top of the same line. So both of these equations are graphed on the same line. That's why it's all real number solutions. Because whatever this ordered pair is a solution, and this one, 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 and it goes on infinitely, okay? So all real solutions mean my lines lie on top of each other. They're in the same location. No solution, they're parallel lines because they can never intersect. An XY coordinate means my lines intersect at one point, okay? So that's what all of these answers mean. It's not just kind of an arbitrary, we're gonna solve for X and Y. The reason behind it is because it tells where my 2 lines intersect. Do they intersect? And if they do, is it one solution or all real numbers, or do they never intersect and it's because they're parallel lines? Okay. So, homework. We said we were doing lesson 56. I hate because my teacher book does not, the page numbers don't match up. It doesn't tell you what page it is. Okay, so we're going to do page 122. Is that right? No, 124.
It's 124, then 156.
Page 124, activities 2. And we said it's numbers 1 through 6. And then, because we did the first and last.
58, activities 2, page 27, and 1.
So page 124, 1 through 6. And then we're doing page 127. Page 127, activities 2, numbers 1 through 3. Make sure you have that written down somewhere. Circle the problems in your book. This is due Monday. Okay, just this is due Monday. So you've got a total of 9 problems due Monday. Okay. Remember, the first one is going to be division. The second one, you can choose how you want to solve. If you want to multiply, if you want to divide, whatever works. Okay. Y'all be so excited because on Monday, we're going to learn how to graph our lines to figure out the solution. Yay! I will have some graph squares if you need them, or if you prefer to have your own graph paper, bring graph paper on Monday. Okay, so if you want to have your own graph paper, bring graph paper Monday. If not, I will have some squares for you. Now, one of the things I need to do is we need to put our tables back. So if you're in the middle here, if y'all wouldn't mind sliding your chair out so we can push these tables back together, that would be awesome.